Till by now. Okay, morning it was 20 students, now there are 40 students. Okay, before I give you guys the program for linked list implementation, I'm just showing you the operations first. I share the screen. So in linked list as well, we have mainly three operations: insert, delete, and traverse. Insert means you will add items into your linked list. Delete means you will remove items either from the beginning or middle or from the last point. Okay. Uh, Same thing. Insertion also same. You can add an item either in the beginning or at the end or in the middle. Then traverse will simply display the content of the link. Traverse means it will traverse through all the nodes and it will show the contents in the linked list. So you can see in this image, this is a linked list with three nodes. That means there are three numbers. So one node comprises of two fields. One is for your data and other is for the link or the pointer to the next node. So in next node also there is a data, then it has the address field. So this portion again has the address of the next node and goes on. So in the last node we have a null pointer. Okay, null pointer means your linked list has like finished, no more nodes. So you can see that in a linked list it's not possible to have empty nodes. Okay, if there are nodes, that means there are some data uh, in the list. But in case of array and stack or queue, remember there can be some empty space, right? Remember last time in queue, we checked that if there can be some empty space in queue as well, and in array as well, there can be empty space. Suppose we are assigning an array of size 10, but we have stored only five values. That means five spaces are still empty. But in case of linked list, there cannot be any empty values. Okay, that's another difference between normal array, stack, queue, or linked list. Okay, there cannot be any empty nodes. If there is nodes, that means there are data. So head will be pointed to your first node, and tail, or you can just say null is the end of the list. So what happens in the insertion? So insert operation can be done in three ways. One is at the beginning. Okay. So when you want to add an item into the linked list, you will simply allocate memory for new node. It's not like you are allocating memory for a data. It's like you are just making some space for your new node because you are going to add a new node. Then you will simply store your data for the new node. Then what you will do, the head will be pointed at the front, right? So what you need to do, you just cut the link between the first node and head. Then you add the new node that will connect it to your previous front node. Then your head will be pointed to your newly added node. So initially we had A, B, C, D nodes and head was pointing to A. So when you want to add an item, suppose E, so head link will get disconnected or you will just cut it. Then when you add the new item at the beginning, so this E link pointer will be linked to A and you will just connect the header pointer to your new node. So similarly, when you want to add an item in the end, so what you need to do, same, you just need to give some space for new node and you need to traverse to the last node. Okay, after traversing to the last node, you will just change the null pointer to the new node. We'll cut that null pointer, then we can say this will be a temp node. Then you will just connect that address to your newly added node, and null will be pointed from the in. Okay. Next, we have another option. We can add an item to the middle, which is not possible in either of your array or stack or queue. We cannot add any item in the middle, right? In normal array and other data structure, we can add either in the beginning or at the end, right? Just from one end, but not in the middle. Even in queue, we can insert item from both ends. We can delete the item from both ends, but we cannot add or delete item from the middle. But in linked list, we can add item in the middle and also delete item from the middle. So to add the item in the middle position or anywhere, it's not only middle, it can be any location, any randomly selected place. Okay. So what we need to do, we just need to, suppose I have decided I want to insert a new node in this location. Okay. So in this location, it will just cut the pointer and it will point to the newly added node. Next, the newly added node will point to your next node. Okay. So in this case, I want to insert something between B and C. So connection between B and C will be cut. Then there will be a new connection from B to E and E to C. So that's why in case of linked list, it's very easy to add something in the middle or anywhere. Location is coming in my only middle or no, it's not only middle, it can be any random place. If you want to add here, you can add here. If you want to add here, here also. Any random place you can just add. They just wrote it middle because normally either we can add in the front or add in the end, right? In case of queue, we can insert from one end and delete from one end. Middle means the middle portion. Middle portion, it can be anywhere, maybe position 2, 3, 4, anything. Middle means not the middle. It's not like if there are 8 items you want to add middle means it will be in the fourth location. It can be any position between first to last. Okay, any randomly selected location between first and last. So next, in case of delete, again same. We have three options. We can either delete from the beginning or delete from the end or delete from the middle. So if you want to delete an item, then you will simply delete the first item and you will point the head to the next one. Suppose A and B, you want to remove A will be removed, then head will be pointed to B. Okay. Then if you want to delete from the end, what you need to do, it will just traverse to the last location. It will simply delete the last item and will set the null pointer to C. If I want to delete this D1, I can simply delete the item and null will be pointed from the S. That means you need to decrease the null value. Okay, it will be null plus plus. Now, if you want to delete an item from the middle, what you need to do, first you need to just cut the connection. Suppose you want to delete C, first you need to cut the connection between the previous one, that is B and C. You need to cut that connection. You just delete the item. Then you just point from B to D. Okay, and this node will be deleted. So just need to make sure that it's like a chain system. What we do, if you want to chain, you want to add one more chain, you will just keep adding, right? And if you want to delete something from the chain, you will just take out one of the sequence from there. Then you can just rejoin it again. Okay, so to delete from the middle, you just need to traverse the element just before the element to be deleted. If you want to delete C, then you will traverse to B, then you will cut the connection between B and C. That means you will simply change the next pointer to exclude the node from the C. Suppose here pointer was pointing at C, you will simply remove the pointer and point it to D, and this one will be excluded. Okay, visually it's clear, I guess. Okay, is it clear visually? Switch case, so I will we have switch case, so why we need linked list? Okay, what is switch case and what is linked list? Can you store item in a switch case? So just think about the question. What did you just ask now? Look at your question. If we have switch case, so why we need linked list? Is it a proper question? What is switch case? What is switch case? While programming we use. What is switch case? Question is still the same. What is switch case? Selection control. Body of the program. Like seriously guys. What's the difference between switch case and linked list? Don't search in Google. You have not understand linked list. Okay, I can understand you have not understood linked list. Tell me what is switch case? মেম মই একো শুনা নাই তুমি কেলে শুনা নাই লেট এন্ট্ৰি মাৰিছা সেইকাৰণে শুনা নাই ৰ'বা তন্ময় কেলে শুনা নাই বুলি কৈছা লেটকে সোমাইছা Dular, first you tell me what is switch case. मैम कैसे डेटा पर कंट्रोल करने के लिए हम यूज करते हैं स्विच केस ओके तो अभी लिंक लिस्ट क्या है वो बताओ पूरा एक्सप्लेन करने का जरूरत नहीं है व्हाट इज लिंक लिस्ट लिंक लिस्ट है क्या वो बोलो। वही समझ में नहीं आया। स्टैक क्या है? व्हाट इज स्टैक? व्हाट इज एरे? एंड व्हाट इज क्यू? Okay, just tell me what is data structure. Collection of data. Collection of data is also list, array, anything. Arrangement of data in any place. So if your data structure is a structure to store your items and your switch case is just the control flow, how can you replace these two things? You cannot store anything in switch case. It's just a way of programming. You can do program without switch case as well. They're just way of controlling your statement, branching, looping, and all. Argument of data. Yes, so data structure is used for storing the data. Just that arrangement can be different, and your switch case is just a control flow. Without switch case, also you can move between different codes. So you can use switch case in a data structure to control the flow, but you cannot store anything in switch case. Are you clear now, Dundar? Your question was really stupid question. Data structure is for storing data. Array structure, this is your array, correct? We store items like 1, 2, 3, 4, correct? We can just store the values here. Then we have stack. Stack is like your inverted data structure, 0, 1, 2, 3. Next we have queue. Queue is also like your, this one is like this one, 0, 1, 2, 3 maybe. Okay. So what's the difference? Okay, let me draw the link list. Link list will be a okay. Now you see in array, in stack, and in queue. These all of them are just data structure just to store and arrange your data. Correct? So array, how you store array? You just put the things sequentially. Correct? You just keep adding and all. You can delete when you add something, then it goes on maybe 5, 6, 7, 8, 9. Correct? You just keep adding things sequentially. Again, in stack same, you maybe keep things like 5, 7, 8, 9, like this. In array, what happens? We can add item and delete items sequentially. Correct? In stack also we can add item from one end and delete also from one end, and the first value is called your top. Correct? We are only concerned about top. We can add item from the top and we can delete the item from the top. What happens in queue? We have two ends. If it is real, we can add from one end and we can delete from another end, which is called front. Right? So you can see in both cases, in all these three, we can add and delete items. At least in stack, addition and deletion is just from one end. Okay, add, delete. In queue, what's the difference? Both ends. In array, what happens? In array, it's nothing like ends. It never follows first in, first out, or last in, first out. We can just access any item by taking the index. So if you want to delete an item, you can just write delete array tools. Then this item will be deleted. Correct? In array, we can access the item by just taking the index. We just need to give the location of a value, then it can be deleted. In case of stack, we can add and delete only from the top element. Only the first element will be removed. Then one by one, we will go down. In queue again, if you want to delete the thing, only the first thing will be deleted. Then if you want to add something, you need to insert from the back end. Yeah, there are different types of queue, like your priority queue, they just follow the priority level of the numbers. That is different thing, but again you need to arrange those things, right, in case of priority queue. Okay, so these three types of things are contiguous memory, or you can say all the data are arranged in a sequential order. Okay, these are contiguous, they are not separated. But in case of linked list, you can call this thing a node. This thing will be a node, and this is also a node. Okay, now in case of linked list, we have two fields. Okay, since this data structure is not connected like your array where one item comes from another, this one is not connected, means connected but not like this way. यहाँ पे बस एक के साथ एक साथ है, but these are lone nodes. Okay, so you just need to store an item, then there will be another field, and this field will have the address. Okay, address of next node. Okay, so in one node you will have your data as well as the address of the next node. So in the next node again you will have some data, then again it will have address of your next node, then other node will also be like that. Now if this is the last node, this last node, this pointer will be set to a null pointer, or you can just say this is another node. It's not a separate node, it's just a pointer. I'm just showing it like this. Then to identify the first one, we use another pointer which is called head. These are not separate nodes, but those are just pointers for the first and the last node. In case of stack, we use the pointer top. Top will be used just to know the front or the topmost element in your stack, because without deleting the first one, you cannot go to the second one, third one, and so on. In case of queue, we use two pointers, one is front and other is rear. ट्रेन का डब्बा जैसा है, हाँ सही बोले, ट्रेन का डब्बा ही है। तो डब्बे में क्या होता है, अगर कोई एक डब्बा निकाल के लाना है तुम उसको ऐसे ही निकाल सकते हो ना। हाँ अभी समझ में आया था, ट्रेन का डब्बा है। तो तुम्हारा ट्रेन का डब्बा एक साथ हो जरूरी नहीं है, ऐसे ऐसे भी हो सकता है। यहाँ पे एक डब्बा है, देन यहाँ पे एक डब्बा है, यहाँ पे एक डब्बा है, then there is another node here. Not necessarily your linked list nodes will be in a same sequence. अभी ये वाला node में you have a data 8 and it will be address. Now you have to see ये address कहाँ का है। तो ये एड्रेस यहाँ का भी हो सकता है, करेक्ट। यहाँ पे एक डेटा है सपोज, फिर यहाँ पे एक एड्रेस है, ये डेटा रीड किया, फिर यहाँ का एड्रेस तुम्हें देखना है। अभी तुम्हें देखना है इसका एड्रेस कहाँ है। नाउ इट मे बी लिंक टू दिस वन, ओके। तो यहाँ पे भी तुम्हारा कुछ डेटा है, देन यू हैव अनदर एड्रेस, देन यू अगेन नेक्स्ट। अभी नेक्स्ट नोड कहाँ पे है वो ढूंढना है। So to find where is your next node, then you can simply check the address of the next node and you will get the node. Okay. Then ये may be somewhere यहाँ है 40 and this is your node. So you can see the nodes can be arranged in any method. Anyway, it should not be like the sequential way. But in case of array, when we define it, it will be just like simple line, correct? फिर यहाँ पे एक के बाद घुसाते जाओ, like your singles packet, both are same. But in case of linked list, your nodes can be just anywhere. It can be dispersed anywhere. Just that you just need to check the address. तो एक नोट में डेटा भी रहेगा, एड्रेस भी रहेगा। तो एड्रेस में तुम्हें मिल जाएगा दूसरे नोट का पता। अभी समझ में आ गया मुझे, मॉर्निंग में अभी थोड़ा पहले तक। ओके ठीक है, सो इट्स क्लियर इन। सो array, stack, queue, linked list, these are all data structures just to store items, correct? Array, stack, queue, these are all like contiguous memory allocation, एक के बाद एक आएगा। But in case of linked list, those are normal nodes like your train का डब्बा। तो your one train का डब्बा तुम फ्रंट में भी डाल सकते हो, लास्ट में भी डाल सकते हो और बीच में भी डाल सकते हो, ओके। तो सपोज यहाँ you want to add something in the front, this is your front, so this will be your head, so you want to add a item, तो तुम कहीं पे भी डाल दो। मे बी तुम यहाँ पे एक नोट डाल दिया 100, तो तुम्हें बस इसको यहाँ पे पॉइंट कर दो, देन यू जस्ट सेट हेड पॉइंट हियर, ओके। सपोज तुम्हें अभी लास्ट में डालना है, दिस इज योर लास्ट नोट, ओके। सो तुम्हें क्या करना है, कहीं पे भी है, मे बी दिस इज योर नोट 200, सो यू विल जस्ट ये पॉइंटर हटा के विल जस्ट पॉइंट हियर, here, then ये तुम्हारा null node हो गया, okay। Now suppose you want to add something here, तो तुमने क्या किया, ये कनेक्शन हटा दिया, यहाँ पे एक नोड लगा दिया, then you just point it to your data, suppose 5, and here with your address, and this address will join this one again, okay। तो पहले suppose यहाँ पे था ना, I just cut that connection, बीच में घुसा दिया, लगा दिया, हो गया। अभी क्लियर है। तो तुम्हारा स्टैक क्या था, स्टैक था तुम्हारा प्रिंगल्स का पैकेट और वो सीडी होल्डर, देन योर क्यू वाज व्हाट, योर मूवी टिकट लाइन, नाउ योर लिंक लिस्ट इज व्हाट, योर ट्रेन का डब्बा, ठीक है। अभी समझ में आया, अभी पता चला हाउ वी कैन नॉट यूज लिंक लिस्ट इंस्टेड ऑफ स्विच केस and vice versa. अभी पता चला स्विच केस क्यों यूज नहीं कर सकते या वे स्विच केस में यू हैव डाउट. यस दोनों डिफरेंट है. ये डेटा स्ट्रक्चर है, यू आर स्टोरिंग आइटम्स, and switch case is just like your if else. If you don't want to use if else condition statement, you can use switch case. Okay, those are just conditional statement or control flow thing. And here you are storing an item. अभी addition delete समझ में आ गया. Okay, then I just show it once again for a clear view. Okay, suppose we have 4 nodes. Okay, so this is your first node. So first node will have a pointer head, then there will be an address of the next node. So suppose this is your second node. Here I have 20. Now it will have the address of the third node. Maybe this one. We have 30 and this one is pointing here. Okay. And you have 40 here and this is your last node. Okay. Now you want to insert an item in the front. So what you will do, cut the head here. Okay, so you will simply put another node here, suppose 5. This is when you want to add in the beginning. Okay, so you will just remove this head. You will just simply connect this pointer here and you will set your head here. Okay, next you want to add another item in the end. Okay, suppose there is another node, you will cut this null pointer here. So you are adding another node here and you will link up this node to here and will just set the null pointer to here. Okay, suppose now you want to add in the middle. Middle means not just the middle, it can be any random location. Okay, suppose you want to add something here. Okay, just maybe here. So you just first allocate a node first and you want to add an item 60. Now you can decide the location where you want to add it, correct? So suppose I want to add it before 30 or after 20. So you will simply cut this link. Okay. After cutting this link, you will just point it here to your 60. Then you will just set this next pointer to 30. So the connection, the previous connection will be cut and you will just make a new connection from 20 to 60 and next pointer will connect here. Okay, this is add in middle. In case of switch case, we add an item. In case of switch case, you want to add again the same question. Switch case, you are not adding anything using switch case. In previous, okay, I guess you guys are getting confused because of the last program. In stack and queue insertion and delete, we use case. But I guess none of you just check the programs. It's like I just explain you the program or I am just giving you, then you just skip it. Switch case was used only to show the choice. It's like a menu thing. If I'm giving you a menu like यहाँ का जीरोनी का जो है ना एक लिस्ट बना हुआ है क्या क्या खाना है so switch case is nothing but your menu. I am giving the choice. Suppose there you want to eat your samosa, so you will just select samosa there. Then once you get the samosa, then the chai wala, the counter, the boy will just give you the samosa, right? Now, if you want it hot, so they will first warm your samosa, then you'll give it. Correct? Okay, leave the samosa. That one is very easy. Suppose you want to eat your chow mein or fried rice. So you will just select the fried rice, right? Just by clicking the fried rice doesn't mean he's also cooking the fried rice. फ्राइड राइस जो कुक है वो बनाएगा उसके बाद ही तुम्हें फ्राइड राइस मिलेगा ना. It's the same thing. Switch case was used only to give you the choice. Without switch case also you can do all those programming. स्विच केस में ऐड भी नहीं हो रहा है डिलीट भी नहीं हो रहा है इट्स जस्ट गिविंग यू एन ऑप्शन इट्स फॉर डिस्प्ले पर्पस. If you want to don't want to use switch case, you can just use if else ladder, anything. Jyotisma Bujisha. Switch case is not for storing. It's just like menu. Bujisha. Good. So adding वाला अभी और किसी को डाउट है इन switch case. All cases are all cases. What case? Part of key case কথা সুধিছা. All cases are like that. Little ma'am, how to identify the node? In array, we identify with index number. If we want to add an item to the linked list anywhere, how to identify the node? You will identify the node with the help of your address. If you identify the first node, the header pointer is there to tell you which one is the first node. Then first node will contain the address of the next node. So you have to check the address to get to the next node. So if here 5 is your front node, how would you know? In array, your A0 means what? It's your first item, correct? A1 is your what? Second item, right? A2 is your third item, then AN is your last item. Okay, this is in case of array, we know it with the help of array. The same indexing thing, it also works for stack and queue. Why? Because those data structures are contiguous memories. These are just structured like this. Correct? Now, linked list is dispersed. It can be anywhere. So, to identify the node, you always need to see the address. Even if you are going to the next node, suppose you are just getting the node 30, you need to see the address field. In the address field, you will get the address of the next node. That's how we identify the nodes in case of linked list. So for the first node, header pointer will be there. If you see a header pointer, then you can identify that that node is a first node in your linked list. Then again, if you see a null pointer, that means you can identify that this 50 is the last node in your linked list. Now suppose in the first one, it has a data and the address. You will see the address. ये address कहाँ का है? So it will show the address of the next pointer which will have 10. So this pointer will link to the next node only. So यहाँ पे 10 data you access that. then you will again check the address. Okay, that's why there is nothing like indexing here. You will see the address here. With the help of address, you will get to know about the next node. जैसे वो अ, इसका क्या ट्रेन का डब्बा जिला इसमें अच्छा है वैसे रियल लाइफ एग्जांपल का अभी इन योर ट्रेन थिंग रेल का डब्बा हाउ यू आइडेंटिफाई योर एसी वाला डब्बा because glasses are different, right? You can just see it. Those are closed glass. But other than that, suppose in the normal train that never had any AC or खिड़की हाँ खिड़की से पता चलता है अभी हाँ गरीब का दुकान गरीब रथ है ना उसमें तो सब डब्बा एसी है नाउ हाउ विल यू आइडेंटिफाई इसका कुछ नंबर्स रहेगा ना वो वहाँ लिखा होता है क्लास वाइज हाँ सही बोला तो यहाँ पे भी एड्रेस जस्ट कनेक्ट करता जाएगा तो लिंक लिस्ट का नोट ऐसे भी रह सकता है मे बी मैं यहाँ पे हूँ मतलब प्रोग्रामिंग लैब में सेकंड नोट तुम्हारा बेसिक कंप्यूटिंग लैब में है थर्ड नोट तुम्हारा आईटी वाला रूम पे है फोर्थ नोट लिनक्स वाला रूम पे है तो अभी फर्स्ट सेकंड तुम्हें कैसे पता चलेगा अभी मैं सपोज फर्स्ट वाला हूँ नोट तो तुम्हें अभी पता है कौन सा है कैसे पता चलेगा तो मुझे पूछना पड़ेगा ना नेक्स्ट नोट कहाँ पे है एड्रेस क्या है तो फिर मैं बोलूंगी नेक्स्ट नोट का एड्रेस तुम्हारा वो वहाँ पे है वहाँ पे जाओ बेसिक कंप्यूटिंग वाला लैब में तुम फिर बेसिक कंप्यूटिंग लैब में गए वहाँ पे जो बंदा है वो सेकंड नोट है फिर उसको पूछा अच्छा तेरे बाद नेक्स्ट नोट कहाँ पे जाएगा कहाँ पे जानना पड़ेगा तो वो बोलेगा आईटी रूम पे है वो थर्ड वाला है तो तुम आईटी वाले पे गए फिर आईटी वाले पे फिर से पूछा नेक्स्ट नोट का एड्रेस कहाँ है तो फिर वो बोलेगा आइदर इंग्लिश लैब और तो हर नोट पे जाके तुम्हें पूछना पड़ेगा भाई नेक्स्ट वाला कहाँ है ठीक है वैसे तुम आइडेंटिफाई करोगे लेकिन एरे में वैसा नहीं करना है सपोज सिक्वेंशियली अगर गया तो पहले प्रोग्रामिंग लैब आएगा फिर लिनक्स लैब आएगा फिर ऐसे एक राउंड मारो बेसिक कंप्यूटिंग लैब आएगा वैसे है ना अभी रूम नंबर भी 100 100 101 102 वैसे जा रहा है बट अगर लिंक लिस्ट होगा जो 100 में है नॉट नेसेसरीली नेक्स्ट नोड विल बी इन 101 इट कैन बी इन 110 so to identify that you need to ask the person in the 100 number room वहाँ पे पूछोगे नेक्स्ट वाला कहाँ पे है तो वो बोलेगा 110 पे जा नहीं तो बोलेगा 120 पे जा like that but in case of array stack you don't need to worry 100 पे गए उसके बाद 101 पे जाओ 102 नंबर पे जाओ ऐसे रूम एक के बाद एक जाते रहो लेकिन यहाँ पे नहीं होगा तो मैं पूछना पड़ेगा कहाँ पे है रूम नंबर जैसे फर्स्ट टाइम कोई स्टूडेंट गया मुझे ये रूम नहीं मिल रहा है कहाँ पे है तो तुम एड्रेस बता दोगे ना ऐसे जाओ फिर ऐसे मिल जाएगा सो दैट्स द लिंक लिस्ट अगर पहले से अरेंज होता कि एक के बाद सिक्वेंशियली आएगा यू नो नीड टू आस्क एनीवन you can just go from one room to another okay समझ में आया okay this thing is going to end very soon so you guys can join again I'm just ending the meeting then we join again